Hi, see this. This problem actually becomes or came from the chapter straight line, right? Because all this is straight line. So obviously it's given that for this given two straight line are perpendicular. So obviously we need to find out the slope. So to find the slope, let us consider the equation of the line. So the first equation, we'll see that it is xe. X is obviously a x plus a minus 1 and equal to 0. So what is the easiest way to find that equation? That easy equation will be that rewrite it in the form of y equal to mx plus c. So therefore, let's write down that. So this implies that y is equal to minus 1 by a minus 1 into x plus 1 by 1a minus 1. So obviously you can see that in this particular problem, what is my slope? The slope is a1. And that's equal to minus 1 by a minus 1. So this is the slope of the equation number 1. So I put this as 1. Let us consider the second equation. Second equation is 2x plus a square y, and that's equal to 1. Let us write down in the same form. So y is equal to minus 2 by a square into x plus 1 by a square. So that again gives you the second equation, and for the second equation by the slope, m2 will gives you minus 2 by a square. Now say that equation, given that equation 1 and equation 2 are perpendicular to each other. So therefore, we'll say that as m1 and m2 are not m1, m2, 1, 2 actually. So just write down. It is given that line 1 and 2 are perpendicular. So therefore, m1, m2 is minus 1. So let's consider that. So m1 and m2 are minus 1. So that's imply that definitely 2 by a square into a minus 1, that's equal to minus 1. So that's imply that a cube minus a square plus 2 is equal to 0. So we get the equation, cubic equation of A. Now obviously we need to factorize it. So let's go ahead and see that. If I substitute A equal to minus 1, this is get 0. So basic remainder theorem. So therefore, we just go ahead and expand that based on that. So we'll say that a plus 1 is a factor. So a cube plus a square minus 2a square minus 2a plus 2a plus 2, and that's equal to 0. That's imply that if I take a square common, it is a plus 1. If I take minus 2a common, it is a plus 1 plus 2 common. It gives you a plus 1. That's imply that a plus 1 and a square minus 2a plus 2 equal to 0. So what is the value of a? That's definitely a equal to minus 1 and a square minus 2a plus 2 equal to 0. But this doesn't have no real roots. Why? You can easily see that if I find the b square minus 4ca, the discriminant of this equation b square, that is 4. And minus 4ca is 8. So it's less than 0. So discriminant less than 0. So it doesn't have a real root. So a is minus 1. So now a is minus 1. So we can substitute this equation. So the given lines. So what is the given lines for my case? It will be x minus 2y, and that's equal to 1. And if I substitute it here, 2x plus y, and that's equal to 1. So we get two equations. Now whenever we get the two equations, we are trying to find out the distance of the intersection point. So to find the intersection, obviously we need to solve this equation. So that's why we write down that equation number 3, 4 and 3, sorry. Now if I multiply the equation number 4 by definitely 2, we'll have 4x plus 2y, that's equal to 2, That imply if I add now, so adding, it's imply that 5x is equal to 3. That imply x is equal to 3 by 5. And if I trying to calculate the y, so therefore by 4, my y is equal to 1 minus 2x. That's imply 1 minus 6 by 5. That imply minus 1 by 5. So therefore, the point of intersection is actually 3 by 5 and 1 by 5 with a minus sign. Now, what is the distance between the point? The distance from the origin will obviously that 3 by 5 square plus 1 by 5 square and the sum, right? So the distance from origin is actually equal to 3 by 5 whole square plus 1 by 5 whole square and square root. So let's go ahead and calculate that. It is 9 by 25 plus 1 by 25. That gives you 10 by 25. So it's definitely square root of 2 divided by 5. So that actually the distance. So therefore, the option D for this particular problem is the correct choice. Hope you understood it. It's a very simple problem, only its application of the perpendicular line, slope of the perpendicular line. And see that this kind of problem is also came in main 2019. Hope you understood the problem. Thank you.